Welcome to our channel. This lesson I want us to do a practical that involves titration. Titration is one of the analysis that tested in case AC paper 3 as a quantitative analysis. Here with me, who is going to demonstrate titration that involves back titration. Here with me, you are provided with 0.1 and 1.0 hydrochloric acid solution T and anhydrous calcium carbonate and 0.5 sodium hydroxide solution. And we are also given phenolphthalein indicator. So I want to go to that. So indicator. We also have a conical flask and a burette of 50 ml, a pipette of 25 ml, 2 empty beakers, label, measuring cylinders, stand to hold the pressure. You are required to determine the mass of the sodium carbonate that was used in the experiment. Welcome to our channel. This lesson I want us to do a practical that involves titration. Titration is one of the analyses that tested in case AC in paper 3 as a quantitative analysis. Here with me, who is going to demonstrate titration. Here is me, who is going to demonstrate titration that involves back titration. Here with me are apparatus given. You are provided with a solution. And you are provided with 1 molar of hydrochloric acid, solution T, and 0.5 molar of sodium hydroxide solution S, unknown anhydrous sodium carbonate of unknown mass solid V. We are also given a phenolphthalein indicator. We also have a conical flask. We also have a burette of 50 millimeter. We also have a pipette of 25 ml. We have 2 empty beakers. We have a label. We have 100 centimeter measuring cylinder. And the report a stand which is used to hold the burette. You are required to determine the mass of the sodium carbonate that is used in the experiment. So measure 60 centimeter of 1 molar hydrochloric acid using measuring cylinder and transfer it to 100. Measure 60 centimeter of a portion of 1 molar of hydrochloric acid using measuring cylinder and transfer it to 100 centimeter peak. So we are told measure that. So we are told measure that on. We are told measure that. Then we have to measure it. We are measuring 60 centimeter of 1 molar of hydrochloric acid, and we are transferring it to 100 centimeter, 100 milliliter beaker. So that is so, and we are referring it to 100 milliliter beaker. Okay, we have done that. We are told add all sodium carbonate, solid V, to the acid in the beaker and the stir gently. Add all sodium carbonate in the beaker to the acid. Or add all sodium carbonate, solid V, to the acid in the beaker and stir gently. And stir gently. So it means now the stir gently. Now stir gently using a glass rod. Use a glass rod to stir gently. So stirring is done. Stirring is done. So we are allowing now the reaction to take place. Now the next procedure is leave the mixture for 3 minutes until there is no effervescence. So leave the mixture for 3 minutes until there is no effervescence. Until there is no effervescence, you leave for 3 minutes. I left that one for 3 minutes. Now transfer the mixture into clean 100 ml measuring cylinder and add distilled water to make 100 of the solution. So you are told transfer the mixture into clean ml measuring cylinder, 100 ml. So this is 100 ml. So I transfer the solution into 100 ml measuring cylinder, and I'm going to add a distilled water to make 100 of the solution. Measure stop. Okay, they said add distilled water to make 100 centimeter of the solution. So now there is that mixture. Now I'm topping up to 100 centimeter cube into in a measuring cylinder of 100 ml. So do. So that is now what we call add a lot. Now I have topped up to make 100 centimeter of the solution now. Now transfer all the solution into 250 centimeter cube beaker and shake well, level this solution level. So it means this is the transferring. So this is my 250 ml beaker. So I'm transferring the solution in the measuring cylinder here. Then after that, I will what? After that, I will shake. I'm shaking. After shaking, level this solution and level. So I'm making this solution level. So this is level. So this is my solution. The solution level. And remember, solution level is our my solution level. Now solution W is the solution which contains 6 centimeters of the hydrochloric acid plus unknown mass of solid V, which is sodium carbonate, and then some water, which is 4 centimeters cube of water because of the top. Now fill the burette with solution S. So this is my burette. This is my burette. I'm going to fill my burette with solution S. I have used solution T, which was hydrochloric acid. Now I'm going to use solution what? Solution S as a pure. I will put it in the burette now. I will put it in the burette. So this is my solution S now. So first of all, I will check whether the burette is working. I will check whether the burette is working. So it means my burette is working. So I'm going to rinse the burette because of it can contaminate and can have a fake result, isn't it? So and I'm now filling my burette with solution S now. Good. So this is my burette. Okay, this is my solution what? Solution S now. This is my solution S. Now I want to fill it up to the 0 now. So I want to fill it up to the 0. I want to fill it up to the 0. So now in beta 0, now I will do that. Now it is now I fill my puree. Pipette 25 centimeter of solution W. Pipette I'm going to use my pipette and then pipette the W that I prepared. So I want to pipette that. So this is I pipetted to the misca. Then I will put into the and transfer to a conical flask. I'm going to transfer to a conical flask. So transfer to a conical flask. I've done that. Now they say add 2 to 3 drops of naphthalene indicator. Add 2 to 3 drops of naphthalene indicator. 1, 2, 3. So that is I've added the naphthalene indicator and titrate with solution S. Now I'm going to titrate with solution S in the purette. Now I'm going to do my titration. So this is I'm going to do a titration. Yes, go with me. Here we go. Yes. So this is what titration means. I'm doing titration now. Good. Now, and I was titrating up to I've seen a color change. That is a pink color because I've added a naphthalene indicator now. So I'm going to read the values now. Come on. So I'm going to read the values. You read the values from here. So my values, my first titer is what? Is 20.4. So 20.4. So that's how I have done my titration for the first one. If you do the first one, you can try and repeat the second one, third one, then you can go on. And from there, I have done my titration. So that is it. And I'm going to do the questions. And before the questions, I will fill the table. After filling the table, then I will do the questions which will thank you. Let us fill. And I've seen I was 24.0. Our average first titer was 24.4. 20.4. So I will start from an initial burette. Now in the initial burette, you write 0.0. You start from that. Then my final burette was reading 20.4. Then I will subtract and get 20.4. Then here I can also have, I was refilling it, 0.0, 20.4, and here is also 20.4. Then 0.0, 20.1, 0.3, and 20.3 now. So I have that. So I will add now, I will calculate my average titer. The average titer is, I will add all 20.4 plus 20.4 plus, I will add them. Then let me add, first of all, I will add 20.4 plus 20.4 plus 20.3. Then I will get a total. Then if I get a total, and I will go on. Then divide by 3. So I will get it, divide by 3, then it equals 20.366. So centimeter cube. So I will leave it like that. 20.3 centimeter cube. That is it. So like in, I will use it. They say if there is 2 digits, the last number should be 0. And if it is that, the last number, so I will go it and get 0.4. I will get that 0.40. So that is it. That is now the average height. Calculate now. Calculate the number of moles of the sodium hydroxide. So my students here, and moles of sodium hydroxide equal to, and molarity of the sodium hydroxide times volume of the sodium hydroxide, the volume used, divided by the 1000. So it will be the molarity of sodium hydroxide. The molarity of the sodium hydroxide is 0.5. So the 0.5 times volume, which is 20.4, divided by 1000. So here the answer will be 0.5 times 20.4 and divided by 1000. So here it equals 0.5 times 20.4. So here it equals divided by 1000. So here will be 0.0102 moles. So this is the mole of the sodium hydroxide. Again, they are asking us find the moles of the hydrochloric acid in 25 centimeter of the solution W. So in that now we are going to write an equation of the sodium hydroxide reacting with the hydrochloric acid to form sodium chloride plus water now. So this is liquid, aqueous, and then aqueous. So if we look now, the mole ratio is 1:1. So if the mole ratio is 1:1 now, and they are asking us the moles of the hydrochloric acid in 25 centimeter of solution W, it means now they are asking us the mole of the hydrochloric acid that reacted. So that is the, if the sodium hydroxide has got that mole and the both of them has the same mole ratio, they have the same mole. So it means now the moles of sodium of hydrochloric acid will be the same as moles of the sodium hydroxide, which is 0.01021 moles. So the other question is determine the number of moles of the hydrochloric acid in 100 centimeter of solution W. So how will we determine that? So it's like, if for example, if 25 centimeter cube of the hydrochloric acid has got a moles of 0.102 moles, how about 100 centimeter cube? So it will be 100 centimeter cube times 0.10102, then divide by 25. So here will be times 100 divided by 25. So that is 0.0408 moles. So this moles is the number of moles of the hydrochloric acid in 100 centimeter solution W. Now, calculate the number of moles of the hydrochloric acid in the original 60 centimeter of the solution. So it means they're asking us the original mole of the hydrochloric acid with the 6 centimeter cube of the hydrochloric acid that we have reacted with the sodium carbonate. So how can we go about that? So we will say moles. Moles will be moles equal to molarity times volume divided by 1000. So here molarity we have, that is 1.0 times volume. The volume of the hydrochloric acid used, it was 20, and it was what? That one was 60. So divide by 1000. So it will be 1.0 times 60 divided by 1000. So that means now the moles is 0.06 moles of the hydrochloric acid, which is the original mole. Now the question G, they are asking us calculate the number of moles of the hydrochloric acid that reacted with the sodium carbonate. So how can we go about that? Remember, the sodium hydrochloric acid reacted two times. One time reacted with the base, and another time reacted with the what? With the carbonate. So, and we have the original moles of the hydrochloric acid now. So how can we go about that? The moles of the hydrochloric acid that reacted with sodium carbonate. So moles of the hydrochloric acid, the number of moles of the hydrochloric acid that reacted with the carbonate will be equal to the original mole of the hydrochloric acid minus the moles of the hydrochloric acid in solution what? In solution W. I see now. So that means now it will be 0.06, that is the original mole of the hydrochloric acid, minus 0.0408. So that will be 0.06 minus 0.04 0.06 minus and 0.0408. So that is it. Now the mole is what? This is the moles of the hydrochloric acid reacted with. This is the moles of the hydrochloric acid reacted what? Reacted with what? With sodium carbonate. Very good. So let's see now, they're asking us, determine the mass of the sodium carbonate that reacted with the acid. Determine the sodium carbonate that reacted with acid. So how can we determine that? Remember, we don't have the moles of the sodium carbonate. So how can we get that? So we will write an equation now. That is sodium carbonate plus, that is solid, aqueous, plus the hydrochloric acid to form sodium chloride plus water plus carbon dioxide. So what happens is you balance it, aqueous, liquid and gas. So balance it, you put there 2 and put here 2 to balance it. So that means now mole ratio, sodium carbonate and hydrochloric acid reacts in mole ratio 1 to 2 respectively. Good. So it means now if 2 moles of the hydrochloric acid reacts, has got a mole of 0.0192 moles. How about 1 mole? So 1 mole will be, so it equals 0.0192 times 1 divided by 2. So that is now 0.192. Yeah, okay, 0.192 times 1 divided by 2. So it will be 0.0096 moles. So this means now the moles of the sodium carbonate that reacted with the acid now. So but the question was not this. The question was the mass. So mass will be equal to moles times RFM. So and moles of the acid of the carbonate was 0.0 0.096 times RFN ilikuwa 106. And how, if you want to know how 106 come from, is you will see the 2 sodium here and 2 sodium. So sodium is 23 times 2, that's 40. And then carbon 1, that's 12. And then oxygen 16 times 3, that is 48. And 48 at 60. 60 plus 4, that is 60 plus 46, that is 106. So if you multiply it, so it equals 106. So it will be 1.0176 gram. So this is the exact mass of the hydrochloric acid reactant. With those few remarks, thank you for watching these videos on this channel. If you see this channel, can you share and comment and subscribe? And asante sana.